Okay, so this is 10 for perimeters and areas of similar figures. Okay, so I want you to recall earlier in the course we talked about a similarity ratio. Okay, if two figures are similar, a side A of one figure and a side B of the other, let's put a corresponding side, are in the ratio A to B. Okay. For instance, squares the easiest to show you this. Squares are always similar. Okay, if these are my two similar figures, they would be in the ratio 3 to 5. Now in this section, it's going to be more useful to us to do the fraction form of the ratio. So the fraction form of this ratio would be 3 over 5. So if you know that two figures are similar, you take one each of the corresponding sides and set up a ratio using those. That is your similarity ratio. Okay? So So 3 over 5 is going to be our similarity ratio for these two figures. Now in this section, if I were to do the perimeter of this figure, the perimeter would be 12, right? The perimeter of this one would be 20. And if I set up a ratio with the perimeters, the perimeter ratio would be 12 over 20, and we simplify those ratios. 4 goes into both, ends up being 3 to 5. Okay, that's because we're still talking lengths, right? So if one side, if they're similar, then the ratio of one pair of sides should be the same as the ratio of the perimeters, because we're just talking 4 lengths that are all in the same ratio. So one of the first things that you need to know is if the similarity ratio is A over B, star this, then the perimeter ratio is A over B. Okay, now if I took these same two figures and calculated the area of those figures, okay, what's the area of a square with a side of 3? 9. What's the area here? Okay, so the area ratio for the two figures up here would be 9 to 25. Now if you compare that with the 3 over 5, how are those two related, I guess? Nope, 9 and 25 don't share a factor, so it doesn't simplify. But you should be seeing a connection between 3/5 and 9/25. Right, and not only are they multiples of 3 and 5, they're 3 squared and 5 squared, okay? And that's not a coincidence. Adding to this, we'll want to say the area ratio is A squared over B squared. Okay, this is a very important piece of your notes. Because if we know the area ratio, we can find the similarity ratio. If we know the similarity ratio, we can find the area ratio using these principles. Okay. So the next things we're going to do, these are really the notes, but the next things, the examples are important because that's how you're going to see how we apply this information. All right, so say we have a couple trapezoids. That are similar. And we only have one length given, but we know that they're similar. Okay. What would the similarity ratio of the small to the large? Small to large would be 6 over 9, and we do simplify those, so it simplifies to what? Close. 2/3. So the similarity ratio is 2/3. Now what if I asked you also to give me the perimeter ratio? We don't have other sides to find the perimeter, but they did this on purpose. If the similarity ratio is 2/3 and that's just a length, then what should the perimeter ratio be? Also 2/3. Okay, so the perimeter ratio and the similarity ratio should be exactly the same. Okay, now using that concept, which you just wrote down in your notes, the area ratio, how do we find that? We square them. So we're going to do 2/3 squared, basically. So that would be 4/9 should be the area ratio. Now, if I gave you the areas of two similar figures, I don't even have to draw the figures. What if I said areas of two similar figures are 81 and 144? Okay, then what is the area ratio? Small to large, we'll keep it that way. You take the areas and set up a ratio, right? So it'd be 81 over 144. You'd want to check and see if that simplifies. Does anything go into both 81 and 144? Three, yes. So 3 goes into both. This would be 27 and 48. Is that right? Actually, 9 goes into both. We could simplify one more time. So 9 and 16. Okay, so your simplified area ratio is 9 and 16. Now, I can find the similarity and perimeter ratios knowing the area ratio. So if the area ratio is 9 over 16, and I want to go to similarity or perimeter, which are the same. Yep.
Are you supposed to square that area to get the...
No, we have the area. Areas in square units. Okay. So if we have area and we want to get back to similarity and perimeter, how do we undo square units? Square root. So I could square root this, but then I'd end up simplifying my fraction. I can square root this. Those are perfect squares as well. So I do the square root of those. So my similarity and perimeter should be what? 3/4. Okay, so if you start with similarity and perimeter and you're looking for the area, you square. If you start with area and you're looking for similarity and perimeter, you square root. Does that make sense? All right, we're going to do one more thing, and it involves proportions. This is probably the trickiest part of all of this. Okay. Say you have two little pentagons that are similar. All right. The side of one, and they're regular, by the way, the side of one is 4, the side of the other is 10. And we know the area of the smaller one is 27.5 square centimeters. And we want to find the area of the bigger one. Okay. This is a process. It's a good one to learn because when we get into volume, it's a similar situation, but then we have area, we have perimeter and similarity, area and volume, and you have to be able to go back and forth between any of them. Okay, so what you're going to do, first step, you have your lengths. First step is we're going to do the similarity ratio. Okay, so the similarity ratio between these two would be 4 to 10, which can simplify to 2/5. That's the similarity ratio. Okay, we're going to convert to an area ratio. So that means I square, right? So if I square my similarity ratio, what is my area ratio? 4 over 25. So I know the ratios of my areas should be 4 over 25. That's when I go up to use my areas. And so step 2, step 1, step 3 is to set up a proportion with the area ratio. Okay, so if my area ratio, small to large, is 4 to 25, then my areas should actually be in that same ratio. So I would put the small area on top of that proportion with A, which represents my other area I'm looking for, on the bottom. And how do we solve a proportion? We cross multiply. So 4A equals 27.5 times 25, which is 687.5. Divide out the 4. And that is 171.875, and it looks like they're going to let you round those to the nearest unit. So that would round to 172 centimeters. So that's actually the use of these area and similarity ratios. You could also do it with perimeters. If they gave you the right ratios and wanted to go back and find a perimeter, you could.